Yeah, my name is Alex. I've been working with cloud technologies professionally for about 8 years now. So right out of college, I got hired onto an Amazon team that was using AWS to build out tools for their studio organization. Then I moved down the road to Riot Games in Los Angeles, where I worked on an internal developer experience team building out cloud deployment tools to deploy their game servers around the world and at scale. Later, I quit my job and went into business with a friend from college. Up until that business failed, I was a full stack consultant with an emphasis in cloud technologies. But now I work at Principal Financial Group in Des Moines, Iowa, as a senior software engineer, leading our insurance correspondence product line with nearly 40 engineers. So let's take a look at our agenda today. We've kind of talked through this already, so we'll just go straight into engineering expectations. So before we get into sort of the technical section of this chat, I want to start by really exploring what these FAANG Plus companies expect from their engineers, because understanding the expectations is the first step to meeting or exceeding them. So some people believe or have heard of this concept of the 10x engineer, that there are certain engineers that are 10x, 10 times more productive than a normal engineer. But my argument to you today is that that 10x engineer is a myth. So-called 10x engineers have really kind of taken on a bad reputation, due in large part to a misattribution of successful characteristics. So that is to say, simply writing a lot of code, even if it's good code, is not sufficient to have a successful career. There's a strict upper limit to the amount of code that we can write in a single day, and that growth is linear at best. But by focusing on the team around us, we can increase that multiplier for all of the engineers around us, which gives us logarithmic growth. So in short, collaboration is how we best multiply our productivity. A true 10x engineer is one that can effectively organize and execute work across a group of people. So now that we've kind of gotten that out of the way, and with that in mind, you may notice that some of the expectations placed on FAANG engineers matches the expectations that are usually placed on senior engineers at other company. And so in general, these FAANG plus companies tend to hire engineers below their level. And so thinking about a focus on design prioritization, how does the work that we're doing fit into the greater picture while still being able to execute at that high level on very specific technical asks? And it's more than just code. This can lead to wider discussions on potential technology solutions, and it's advantageous for the entire team to be well versed in the trade-offs between all of our different options. So in short, FAANG companies, if you're a senior engineer at your current company, you'd likely be a mid-level engineer at FAANG, just in terms of normal job responsibilities. So part of being a successful engineer is the ability to adapt to the team and problem space that you're in. So Amazon calls this fungible engineering, and that's the idea that hiring folks that can learn what they need to do while simultaneously deliver on work is how that we can best make use of our resources. And so rather than hiring somebody who is an expert in Java, for example, we'll hire somebody who has good experience with high level languages. And if they need to learn Java, they can learn Java on the job. And this is really similar to the concept of full stack developers. We do what needs to be done regardless of where it is in the stack. And we should try to understand concepts generally. Otherwise, we risk locking ourselves in. And this is where our interview skills and our career skills differ slightly. So if we think about, let's say you're an expert in Rust, but you find yourself on a TypeScript team, you'll need to learn the language, its ecosystems, and their idiosyncrasies. But of course, the benefit here is that your knowledge of other technologies can still be applied. So like we've discussed, a successful career is more than simply writing code. A lot of what we do involves prioritizing work and weighing trade-offs. And so that's one lesson that I learned very quickly, is that even in these large tech companies, there's a mountain of technical debt. And we need to set aside sometimes our idealism and our perfectionism in favor of pragmatism. Which work is most important today and what enables us to move more quickly in the future. So, in order to help us prioritize work, we need to understand some of the core tenets of successful software development. And though there may be more, these four tend to be the most common. And these sort of serve as the foundation for engineering expectations throughout the industry. So, we'll start with scalability. And so, just in our minds, even though a product may work at a small scale, how does it deal with large amounts of traffic? And we need to consider things like, is the traffic consistent or spiky? How can we right size our services so that it matches not only the throughput that we need, but also the the traffic pattern that we expect? Second piece here is maintainability. Getting something done fast makes our product folks very happy, but when we complete delivery, we know that there's going to be additional work waiting for us. And so, how do we balance the speed of delivery with ease of fixing bugs? Next piece is performance. We may want to optimize for low latency or high throughput, but that may have impacts on cost. And so parallelization is great, but performing 100 parallel operations is inefficient compared to batching them together. And so, of course, as you become an expert in a language, you'll start to understand the optimizations that actually make the most impact based on the ecosystem you're operating in. Last piece here is reliability. Sometimes this becomes an afterthought, but understanding the service level agreement your service provides is very important. So thinking about things like latency, error rates, maintenance schedules, these are really critical considerations for a mature service. And so with these core pillars in mind, let's talk a little bit about how we can position ourselves for success. So, as we think about this fungible engineering, full stack development in general, it's really important for us to think holistically. Full stack development is sort of generalist by nature, but we can stand out from the rest by having a specialization as well. And so the way that I like to think about it is what I call the T-shape engineer, or what we call the T-shape engineer. And Riot talked a lot about this concept. And so if we think about this uppercase T, we as engineers want to have a broad set of knowledge like the top of the T, and a few things that we have a deep knowledge in, and that's that tall part of the T. And so identifying what it is that you are an expert in, as well as how what you're an expert in fits into the ecosystem around you, is sort of the foundation of this T-shaped engineer. Now, the other piece of this is that nobody can be a square, right? Nobody can be an expert in everything. So understanding your niche and how it fits into the other parts of the stack is sort of how we can make ourselves a unique resource. And again, this really allows us to identify and evaluate trade-offs. So we're going to take just a quick second here. If there's any Q&A on this first section, feel free to put them in the Q&A. I am checking to make sure we're caught up here. Yes, business ask what you're building and why build the bare minimum. We're going to talk a lot about some of that system design stuff here towards the end of the class. All right. I don't see any other questions in the Q&A. Feel free to drop them in there as we keep going along. And so next we're going to get into the actual meat and potatoes. So here's a question. So is it good to be a T or a bar? Our goal here is to be a T. We want a bunch of things that we know a little bit about and a few things that we know a lot about. So that's that concept of that T-shaped engineer. Prefer to be a T. So the next question is, does the generalist part of the T-shape include interests, just not just technical skills? And I would say yes. I really like the idea of T-shaped everything. Really thinking about how you position yourself, not only in a technical space, but in non-technical spaces as well. What are you really good at? What are things that you know a little bit about or that you're kind of good at? And sort of understanding that is a really good way to position yourself professionally and honestly personally as well. All right. Sweet. Okay, so we have a couple of questions in here that are going to come in that we're going to kind of talk a little bit about as we get into the question answer section, or excuse me, into the interview section. So I'm going to come back to you on these. Um, and the last question here is it recommended that you have tea or can a bar work too? I would say it depends for technical roles. Usually you need to have something that you are a deep expert in. So really be pushing for that tea. Early on in your career, most people are going to start as a bar, like you're calling it. And so, yeah, spread things out, figure out what you're interested in, and then as soon as you find something that you're interested in, start to develop that intermediate and advanced knowledge of that topic. Sweet. Okay. Um, I will come back for the remaining questions here. Let's get into the actual interview mindset. Now that we're sort of in that interview mindset, we want to talk about how to approach these interviews. And generally, interviews at this level are going to have three sections. There's going to be a coding exercise, a design exercise, and then behavioral questions. And for each of these, we're going to consider the type of question that's asked, some of the most important parts of your answer, and just sort of some of the thought processes that you may want to consider as you're going through. And so for these three sections, they can come in any order, but we're actually going to get started with a technical question. So hopefully this isn't the first time you've heard this phrase "think out loud," but as these companies are looking for fungible engineers, the most important part of this process is to show how you think. Right? Again, we're not looking for people who are an expert in Java or an expert in TypeScript or an expert in name your language necessarily. Some jobs are that way, but most of the time when people are applying to these FAANG Plus companies, they're looking for people who can demonstrate that they have the chops to talk about technical problems and will teach you the tools that you need to actually take it from your brain and put it into a machine. So again, thinking out loud, we may want to read the prompt silently, but as soon as you start to begin thinking about your solution, you should start thinking out loud. Again, the goal here is that we can show the way that we are processing the problem. If you type fast, adding comments at the top of your solution may also help you, but it also gives your interviewers longer to see and understand your high level approach. So feel free to use that as a tip. So before we start solutioning, we want to start by asking some clarifying questions. And so we have this sort of classic leak code style questioning, asking about grouping anagrams together. So most of the time, these technical questions are going to be sort of intentionally vague or leave out some important requirements. And we can always ask about them later when we find them, but demonstrating that we're thinking about the entire problem at the outset is definitely best. So yeah, some questions we might think, does the output need to be in any particular order? And is there a target complexity? Are there any sort of memory constraints? A lot of times, we're going to talk about this in a second, but those questions may become the second and or third part of the coding section. So usually the way that this will work is they'll start and they'll say, let's write a solution. Then let's see if we can make improvements. And whether that is an algorithmic complexity improvement or adding some extra constraints, perhaps trying to do this in a fixed amount of memory, that's where things can start to get a little bit more challenging in these types of questions. And so my tip for all of these is start with a naive solution and then make improvements. We want to focus on the important parts and not spend too much time on boilerplate and really focus on what the data structure and traversal algorithm we're going to use to solve this problem is. Um, So, things to consider. We want to pick a language that we're comfortable with, and some languages are more suited for certain questions. So, having two or three languages that you feel comfortable interviewing in, and then picking the language based on the question is entirely valid, and I would recommend doing that. we kind of touched on this, but preparing to provide that algorithmic complexity of our solution and thinking not only about like the big O notation of worst case, but also little o and omega O's, these best case, worst case, and average case, all of the type of algorithmic complexity that you may or may not remember from studying. Be prepared to answer those. And a lot of questions are going to have two or three parts that will build on each other. And we want to make sure that we're answering those one at a time. So again, takeaways, most companies don't care which languages we know. The important part is the logic. Understanding trade-offs between that algorithmic and space complexity is important, and especially at these FAANG Plus type companies, being able to re-implement the same solution, but with a different constraint, whether that is a more restrictive constraint on the time complexity or a more restrictive constraint on the memory complexity. Very common as follow-up questions. But in general, I really like to think about these interview problems in three steps, starting with that naive solution so that we get something done, then focus on what changes do I need to feel comfortable taking this solution into a production environment. And then the last piece is that sort of golden path. If we were given all of the time in the world, how would we improve this to make it the best possible solution to this question? And so just at a high level, we're going to go through this question, given an array of strings, group the anagrams together. Somebody's already got their hand up. So yeah, let's, actually, I don't think I have permission to ask anybody to unmute. If you want to type your high level solution into the chat real quick, we'll give you just like a minute to see how you're feeling on that. And I actually don't have permission to let anybody speak. So I see that you're raising your hand, and I'm sorry that I can not
I
unmute you.
can do that. If there's anybody who has a valid question, please drop in on the Q&A first so that we can screen it. That would be super helpful for us, or maybe on chat. Alex, would you want to take a live question? I think Venkateshwar has, how can golden solution be expected with limitation of interview? If you want,
Yeah, so fantastic question. So I don't think that anybody's expecting the golden solution. And in fact, especially if somebody comes with a golden solution quickly, that's usually an indication that they've seen the problem before. And again, that's not actually really valuable for us. We don't care as interviewers how many problems, how many of these leak code style problems you've done and solved correctly. Again, our focus is trying to understand how you think. And so to your question on how can that golden solution be expected, it's not expected. Again, the focus here is, can we get something done? And then if we can get it done, can we get it to be something that we're proud of? And then if we have time to, still continue working, focusing on, if we had more time, how would we continually improve it? That golden solution really is unattainable by design, so it's not expected. Uh, Perfect. So use the dictionary to figure out characters in each string. That is very similar to my solution. So let's kind of walk through this. I sort of mentioned that the two big things for any of these technical questions is the data structure and the algorithm. So we're going to start with identifying a data structure. And the solution here that I'm proposing is basically just a hash map that goes from some anagram identifier that's unique for a specific set of anagrams to a list of strings. And that anagram identifier could just be the letters in sorted order. And if we were to have a hash map that has the sorted letters pointed to a list of strings, we could obviously just get the values of that map to see. So yeah, a lot of people coming in with very similar answers in the chat. The algorithm here, for each element in that input array, we're going to sort that string and put that string in a corresponding hash map entry. And then this is a great opportunity to use the reduce function. So this is some pseudocode that we put together. It's very inspired by TypeScript, but this is actually pseudocode. Broadly speaking, pseudocode is the de facto language of programming problems. Like I said, I would much rather us walk through your logic, even if it's not something that compiles. Again, the focus here is how do you think? So it's totally valid to use pseudocode. A lot of companies now are allowing you to just run the program on your local machine, your local IDE, whatever you're most comfortable with. So if you're the sort of person who likes to be able to run things through and get, live hints and error messages, um, totally fine. If you're the sort of person who much prefers to just sort of write the process out in pseudocode, also an entirely valid way to approach this. How much time are we typically given to solve these problems? For the most part, you're going to be looking in the 20 to 30 minute area. It's going to depend on the company. It's going to depend on the role. Some people will have, a full hour for technical problems, but the normal technical problem is about 25 to 30 minutes. Does the solution always have to be solved? Not necessarily. I would say that like if you don't get to the end of the interview having some sort of solution, the question is going to be, did we think about a naive solution and didn't implement it, or did we just not understand the question? So this is, I think, more often what I see is people trying to over optimize initially. Again, this idea of let's start with a naive solution is really so that we get to this point so that at the end of the interview, we don't say, oh, well, they didn't solve the problem, but they looked like it was okay. Much better for us to have naive solutions so that we can check the box and say we solved the problem and then spend that time improving it. So the solution doesn't necessarily always have to be solved, but you should try to make sure that you solve it. So how to approach a question which you've already seen. Should I discuss the brute force and optimize or discuss the optimized solution? So I find that the best case for this is to just tell the interviewers that you've seen this problem before. And one of two things will happen. Either they'll say, okay, you've seen it before, we'll give you a different question, or they'll say, let's keep talking about it anyway. In the let's just talk about it anyway, we go straight for the optimized solution to show, yes, in fact, not only have I seen it, but I can recall it and actually put it together. But more often than not, they'll just give you a second question that you hopefully have not heard of. I would not recommend pretending like you've not seen a question before. I would not advise that. If the interviewer is in a hurry, is it okay to give just the optimal solution? So to be clear, I'm not saying let's do the naive solution just to show that we're doing the naive solution. This is, if you know the optimal solution to begin with, sure, fine, go for it. But I think more often than not, especially with some of these more tricky technical questions, there are pieces that are intentionally designed to trip us up. And so thinking that we can go straight to the optimal solution is how we can end up in a case where, well, we got 80% of the way through the optimal solution, but still nothing that works, versus getting 100% through something that is maybe not optimal, but then works, and then be working on the improvements. So it sort of depends on your approach. But I definitely recommend starting with the naive solution. Cool. In terms of algorithmic complexity here, obviously we're iterating over all the values in our input array. And then for each of them, we're doing a sort. So we're on the order of O of n, and then m log n, where m is the length of the string and n is the number of elements in the input. And then in terms of space complexity, we are building up this array of objects, an array of, an object of arrays. And so our space complexity is going to be on the order of O of n. So certainly, if you are looking into these FAANG Plus companies, I'm sure that you've been spending at least some amount of time on LeetCode or some other sort of coding solution practice system. So we're not going to go into any more of these technical problems. They are very much out there. Go and practice them. That's the best advice I can give you. So instead, we're going to take a second and start talking about some system design interview questions. And so I said before that like what makes a fungible engineer successful is their ability to identify and weigh different options against each other. And this is where that broad knowledge and deep knowledge really comes together. And so we're going to go through a few examples of different architectures and how we might think about that application in the real world. And so we're going to be taking a look at an architecture diagram and see how we can improve the system. And so most of the time, oh, is this out of order? Oh, excuse me. This is our mindset. This is our mindset of how we're going to approach a system design question. We're going to follow the data flow and ask questions. So again, we're going to take a look at the inputs and the outputs of the system and figure out what sort of transformations actually need to be applied. And also start to think about things like how large is the data and does that restrict any part of our solution? Um, Identifying latency sensitive components, understanding the SLA. Does this need to be synchronous or event driven? We'll talk a little bit more about that in just a few minutes. But again, we're really focused on this optimizing of the end user experience. Can we make the input synchronous and the output asynchronous? And do we need to pull fresh data when we begin processing asynchronous parts of the system? My recommendation in general for these system design problems is start with a pencil. And depending on the system, it may make sense to work backwards from the input or the output. We want to start with this high level outline and then fill in the details. And we want to think about implementing robust monitoring and error handling to make sure that system is reliable and available. Now, with that said, starting simple, starting with the naive solution still applies here. So while it's great to think about the monitoring and error handling while you're going through the entire process, we really want to make sure that we have something complete from end to end, even if that is just a happy path. So things to keep in mind as you're going through this. The other thing is we want to call out assumptions. So thinking about things like auth and security, again, very important, but it's usually not the point of the question. We want to really consider defining subsystems that can be expanded upon after we complete that initial outline. So things to consider, inputs and outputs for each step. How does that fit into the overall goal of the system? Thinking about data stores, what sort of querying needs to be supported and at what cadence. Help us determine should we go with a relational database or a key value data store. And then where can efforts be deduplicated? How do we balance that between component and architectural complexity? We're going to talk a little bit about microservices and monoliths here in just a second, but that's always going to be one of the trade-offs we have to decide between is do we want our code to be very complex or do we want our infrastructure, our architecture to be very complex? Understanding the API between each step of our process really allows us to critically examine that existing architecture. And again, the idea here is we're going to be given some sort of system design map, some sort of PDF or some sort of diagram, and we really need to explore how can we make this better. Understanding each step of the process as it exists allows us to better understand what we need to solve. Key value data stores, very efficient and cheap, but sometimes we do need to use relational databases. So understanding query patterns for key value data stores, when do we actually need to use SQL in a relational database? That's a very important piece of these system interviews. And last piece here, we want to deal not only with the happy path, but also with the sad path. What should happen when something fails? Again, that's really focused on that monitoring and error handling. So start with the happy path, but make sure that we're also considering the sad path as we go through. All right, we are going to take a little, all right. So again, we're going to circle back to that system design question that we were just looking at. And really, again, our focus here is on identifying and evaluating trade-offs. So here's an architecture diagram. How would we improve or optimize this system? And I'm realizing my next slide is entirely messed up. So we're going to skip through pieces of this so that we can get it all out there. Again, we want to start with the clarifying questions. Where are our service boundaries? What is the input and the output? We want to know if there's any specific problems with the system. If we take a look at that diagram, you'll notice it's sort of a microservice architecture, but there's a bunch of different microservices that call other microservices. And so a specific known problem for that system was high latencies. And then other things we want to think about, are there any non-functional requirements, including service level agreements? And again, start with that naive solution, then make improvements. We want to focus on the important parts. And again, low-hanging fruit are important to call out, but we want to think about how it fits into the larger picture. Low-hanging fruit is another example of that naive solution. Let's start by identifying things, showing that we know at least bare minimum where we can start to make improvements, and then use that time to build out our larger picture. Oops. Again, start with the pencil. We want to start with that high-level outline of how we would evaluate a move to these microservices, what service boundaries make sense and why. Think about code ownership, team autonomy, feature velocity, component coupling, and how, again, would we ensure observability, monitoring, and graceful degradation during and after the migration. So I'm going to hop back actually to our diagram for just a second here, and I'm going to give you all an opportunity if you want to raise your hand and talk about, do you have any questions that you would ask for clarifying, or if you want to take a stab at what you would do to start to improve this service. We'll take just one person take a stab at it. Not seeing any hands, so we'll just go kind of straight into this. Again, one of the big problems that we had in this problem is that we had the high latency, and we can see in this system diagram that if we needed to retrieve something from the device DB, from that device service, depending on how we go, we could end up actually making 3 separate HTTP calls, and when we put those all together, that becomes it takes a long time. So one of the ways that we could simplify the system is by starting to bring things down together into a more monolithic service than this. And that really gets into the point that I want to make here, again, talking trade-offs of monolithic architecture versus microservice architecture, and how do we sort of find a happy medium between these two types of architectures. And so we're going to start by talking about monoliths and microservices. And so many engineers will sort of be instantly opposed to monolithic architecture, if only because of the industry consensus against them. However, monoliths do have positives to weigh, and they may be the right solution for certain problems. So monoliths are usually a single executable service that resides in a single repository. It combines business logic, data access logic, even UI distribution logic together. And as a result, monoliths are relatively easy to deploy and debug, even locally, especially for small teams. It's all in one application. However, since all of that logic exists in a single executable, we're not able to scale individual models independently. So if we needed a certain amount of RAM or CPU for a certain endpoint, other endpoints will have a server that's over provisioned for them, which can eventually become expensive. A lot of the value we provide in architecture is right sizing our solution to the problem. And whether that's making sure that we are not over provisioning certain endpoints, or that we are making sure that the compute we need to respond to requests is as approximately close to our demand curve as our traffic curve as we possibly can, is how we can optimize that. And of course, as our team grows, we risk a massive number of merge conflicts while everybody commits to a single repository and potentially a lot of shared code. And of course, there are ways that we can get around these downsides of monolithic architecture, but let's consider another popular architecture to sort of see how it compares. And that is the microservice architecture. It's been a really hot topic in our industry for a long time. Microservices are usually multiple separate services split into many different repositories. And the idea is that we can separate disparate logic into simpler, smaller services, which is very similar to the Unix philosophy of doing one thing and doing it well. And now, since the services are separate, we can scale them independently of each other, allowing us to right size based on real world requirements. However, since we have many separate repositories, we may need to have separate deployment pipelines. And we also need to start to consider breaking API changes more thoroughly. So if we think back to that example before, if we have a user service and we remove a field from that model, any other service that consumes our user object has to be updated and ideally updated at the same time. Suddenly we have to deploy multiple services simultaneously in order to prevent interruption to service. Now, one solution that we could use to get around this is versioned endpoints, which is really the true solution to this microservice architecture problem. But by having versioned endpoints, that's starting to require that we maintain two separate versions of the logic until all of our consumers have updated to the new version. Now, for public services, like we think about maybe a Facebook or an Instagram API, that makes a lot of sense because we don't have control over how long it takes our customers to update to the most recent version of our endpoints. But in a private API, if we are the only consumers of our service, maintaining two separate implementations of the same code can start to become a sticky wicket from a maintainability perspective. Another common issue with microservices depends on how deep a single call could go. And so just like we saw before, if we have that API service that calls to a user service, but the user service has to call to a device service, we've now tripled our latency and our execution count. So one of the benefits of microservices, especially microservices running on Lambdas, is that we only pay for the usage that we actually use. And in general, we'd like to keep that almost at least proportional to the number of requests that we receive to our API. So if our client sends a single request, but that invokes three separate Lambda functions, three separate microservices, now we have tripled our overall cost compared to trying to collapse that logic down into a single Lambda execution. And so not only does that potentially cause timeouts, it also drastically increases costs when running in these serverless environments. And so we have to weigh trade-offs between maintenance complexity and code complexity. And certainly in most cases, these trade-offs are better than in a monolithic solution. However, what if we could find like a middle ground? And this is, again, the goal of our trade-off analysis is how can we get the best of both worlds? And so one pattern I've become a fan of kind of recently is what I refer to as the distributed monolith. And conceptually, this is the middle ground between microservices and monoliths. And the idea here is that we have a single repository that defines multiple services underneath. And so we can think about like a CDK project can deploy multiple Lambda functions simultaneously. And so since we have multiple services, we can still scale them independently. And because they're in the same repository, we can share the models very easily. Any breaking changes can be fixed and deployed simultaneously. And so in practice, this architecture works well when we have other cloud services connecting the different components. And so a Lambda-based API may accept an HTTP request and then put it in a queue, which then triggers a processing Lambda. Now, one of the downsides, again, one of the trade-offs of this solution is that it requires really well-defined contracts between our components. What's the shape of the data we're sending through each of these queries? And so that gets into sort of my main point when we're thinking about not only engineering at FAANG Plus companies, but also being an effective upper-level dev, which is we can do almost anything, but should we? Again, I'm not trying to convince you to use any certain type of architecture here, but instead I'm trying to highlight the most common problem in software engineering, which is how do we pick between our different options? And so again, in general, software engineers can do just about anything, but it's our job to really raise the flag when something isn't practical or something isn't quite right. So let's apply that same thought process to another problem, which is choosing a data store. And so we'll start by considering a key value data store like DynamoDB. And so key value data stores are very horizontally scalable, so it can handle a lot of traffic very easily. It's very efficient, sort of like a hash table, really fast lookups for key-based access. Arbitrary queries, though, could cause expensive table scans, which affects performance and cost. One of the benefits of these key value data stores is that they're schemaless. And so that allows us to store data sort of flexibly without predefined schemas or structures. It's optimized for real-time applications with low latency access, and then automatically handles scaling and partitioning. So high availability, fault tolerance is all built into our database runtime. Last piece here, eventual consistency is really just ensures our availability over strict consistency in distributed environments. So those are key value data stores, and broadly are the sort of things that I push people towards using whenever possible. But there are times where we can't use key value data stores. And so there's still a place for relational databases. Relational databases tend to be focused on vertical scaling. So rather than having more nodes, we would add more resources to a single node. Works really well when we have to have some sort of like SQL interface. So structured queries or something that needs transactional consistency. Getting into ACID compliance, making sure that we have that reliability, consistency, integrity of those transactions. But where relational data stores really add value is their ability to do joins and complex queries. So relational data retrieval, normalization, as well as adding indices and optimizations. I'm going to hit a couple of questions here real quick just because I see them here and it's related. Are TOML and YAML files still considered key value data stores? I'm going to say not in the way that we would think of a data store. I think, you could make an argument that TOML and YAML files can be simplified into some sort of object format, which would then be considered key value, and it's storing data, so it's a data store. But I wouldn't say that a YAML file is a key value data store. Perfect. Sweet. So we've talked about relational databases. We've talked about key value databases. They have their benefits. They have their drawbacks. But again, how can we take both of these and make the best of both worlds? And so what I like to think of is what I'm going to call a hybrid data store. And the idea here is that we can use the best parts of a key value data store while shoring up some of the trade-offs by using both a key value data store and a relational data store. So having a key value data store as the source of truth, a DynamoDB table, that is, if we need to update, insert, delete a specific entry, we go into the key value data store. But then we can use event-driven change propagation to make that change elsewhere. So if we needed to have a complex query running against our data store, we could essentially mirror the data from DynamoDB into a relational database like PostgreSQL. It would require us to run regular reconciliation to make sure that the things are still in sync. But the benefit of this is that we would have the scalability and cost optimization of a key value data store while still having the ability to perform arbitrary queries and joins and lookups using a relational database as needed. And so, as before, this may not be a feasible solution every time, but by identifying the trade-offs for each of our options, we can consider creative options that minimize the drawbacks across the entire system. All right, so we've talked about technical coding problems. We've talked about system design problems. The last piece here is behavioral interview questions. And so hopefully you've heard of this, and if not, this is probably the most important thing that we can talk about, which is the STAR method. So behavioral rounds, the questions are always going to be something of the effect, tell me about a time, have you ever done this, tell me about it. But most of them are going to start with tell me about a time and then whatever they're interested in. So an example of this question, tell me about a time you had to give hard feedback to a coworker, is almost verbatim a question that was asked me at Riot. And so when we're approaching behavioral style problems, we're going to remember STAR, which is situation, task, action, and result. So we'll start with that one at a time. So tell me about a time you had to give hard feedback to a coworker. We're going to start with the situation, which is the background and the context that this is all happening in. So there was an engineer on our team that was consistently taking too long to complete tickets. We had high priority feature work to complete, and our deadline was looming, and we couldn't hit that deadline without some sort of change. That's the situation. There was, and then the situation. The next piece is the task, which is the goal as well as your role within this story. So in this case, as their manager, I needed to determine why this engineer was not able to complete tickets in a timely manner. That establishes what I need to do as well as why I'm expected to be the one to do it. Am I going above and beyond, or is this a part of the responsibilities of the role that I'm already assigned? After finding out why it was taking so long, I also needed to find a solution to the problem. So, first two pieces of STAR, situation and task, is really setting the scene. Now that we understand what the situation is, who you are in this situation, now we can start talking about the actual action to be taken. Last piece, I didn't realize I had one. We also needed to fast track work to hit our deadline. Sweet. So now that we understand the situation and task, let's get into the action, which is what you actually did. So here, I told the engineer that the team was worried about their ability to complete work accurately and on time. And then together, we identified that the tickets were too vague, and this resulted in multiple iterations for a single ticket. The action is what you actually did. The last piece of this is the result. So, because I took this action, this is what happened. Here's the outcome. Was it successful? What would we do differently? After breaking down those tasks further, our team was able to identify difficult issues before assigning the tickets. And after a few months with that engineer consistently delivering on assigned work, the team's confidence was restored. So that is situation, task, action, and result. Okay, so let's get into sort of a live trial test here. You all should have access to the chat. And so what I'm going to do is I'm going to put up a behavioral question here. And if you want to go ahead and spell out your answer in terms of STAR methodology, situation, task, action, result, we'll go over a few of them. And so here is the question that I would like you to think about. Tell me about a time you encountered a difficult technical challenge. How did you approach the problem? What was your situation, your task, your action, and your result? And while you all are typing there, I'm going to see if I can answer a few of these questions in our Q&A. Okay, so the first question we have here is going back to our code question. Will it be okay to provide an O of n squared as the first solution and don't have enough time to provide, say, an O of n in 30 minutes? Again, okay is really going to depend. I would rather have you be 100% complete with something that is imperfect than 80% of the way to something that is perfect. But that's going to depend on your interviewer. That's going to depend on the company. In general, it's better to have something that is complete than something that is incomplete. So is it okay? Yes. If only because we have something to show. What would be not okay is if we tried to get that O of n solution in 30 minutes and we didn't get that n squared solution first. Then we have nothing. So that is one thing to think about there. All right, our first star here. Understood the pain points, understand time and effort available to solve the problem, find the simplest methods to solve the challenge, and iterate over to make it better. Yeah, I think this is a good high-level approach. Obviously, it's not quite the same if you're just, typing it out. But yeah, making sure that we have some sort of situation, some sort of task. This is definitely the action and the result. So that's good. Here's a question. In some small-sized companies like mine, startup to a small company evolution, how do we answer such a question in a star format if the method to deal with such situations are non-standard? Deal with some situations are non-standard. I don't think I quite understand this question. Um, I think broadly speaking, you'll be able to understand the goal of the question. For example, all employees are stellar. Okay, so if it's something that is a question that you have not run into before, so in the question before where you had to give hard feedback to a coworker, if you've never given hard feedback to a coworker, I think it's important for us to say, I've not done that, right? We never want to sort of like make up situations. Um, but I think if you can get into the goal of the question, right? Maybe the question about tell me about a time you had to give hard feedback to a coworker. You've never done that because every coworker you've had has just always been stellar. Um, Thinking about hard feedback that you've given maybe to a friend or to a family member. Again, the purpose of that question is like, how do you give feedback? And so that's what I would start by saying. It's like, I've never had to give hard feedback to a coworker. I have had to give hard feedback to a friend. And they can either say, well, tell us about this time you gave hard feedback to a friend, or we can offer to say, this is how I would try to approach it, right? It's never a bad thing to say, I don't know. That humility is something that's really, really, really important in these interviews. So, so when answering, should we mention the title like S, T, A, and R, or should the response should explain itself? So you can go either way on this. I think the important thing to remember with these FAANG Plus companies is that most of the time the interviewers are following a rubric, and most of the questions are going to be associated with one or two rows of the rubric. And so as we get into behavioral questions, most companies are going to be trained to say, were they able to identify a situation, a task, an action, and result? And so I don't think there's anything wrong with saying, here's the situation, here's the task, here's the action, here's the result. If anything, it shows that you know sort of what you're talking about from an interview perspective. But you certainly don't have to do that. I think if it makes sure that you are saying every piece, all four pieces of it, that's great. But as long as you're saying the four pieces, you don't need to necessarily have the title. Here's an example. Situation. It was a last project where a screen was blackout in normal run mode. We needed to identify a way to reproduce the issue on the bench and find the code component which is not working as expected. The action was divided and debugged various components separately with the same input to see the output of each SW component, and then identified the SW component that was not giving correct outcome, and the result was memory allowed to that SW component was managed in an effective way to resolve the issue. I think that is software. The SW is software. That makes sense. So yeah, again, really good breakdown. STAR, wonderful. I think the only thing that I would sort of improve about this is, and this is more optimistic than anything, is if we can quantify the result in some way. Obviously, with the question before, hard feedback to a coworker, it's hard to sort of quantify. You know, oh, we increased his productivity 33%. But if you can put numbers to something, and this is true not only in your interview questions, but also especially on like resumes, if you can say, you know, we reduced latency by 30%, that number, being able to quantify it, is super, super valuable. Somebody says, I always end up using a lot of technical details in the behavioral questions. That was the feedback I got from Amazon on-site interview and led me to fail the last step. Is that okay, or better to keep it high level? If I have to keep the response non-technical, how do I do that? So I think the high level piece of this is, well, let me back up. One of the questions that I ask frequently is, tell me about a time where you had to explain a technical problem to a non-technical audience, or a non-technical problem to a technical audience. And so that is definitely an important piece of this process as well. So if part of the prompt is try to keep it non-technical, try to keep it non-technical, right? Even if you know your interviewers are technical people, if they're telling you to sort of treat them as if they're non-technical, that's definitely my recommendation, because a lot of that is trying to understand. Sure, you can talk the talk to technical people, but how are you going to work with people who are maybe product people or business people who don't understand the day-to-day workings of code, but still need to direct the direction of our product. Here's a really good question. How long should we take to respond to a question? So in general, high level, if you could get it down to 4 sentences, that would be ideal. If you could have a perfect situation, task, action, result, each 1 sentence, that would be ideal. The number you provided here, 60 to 90 seconds, I think that that is a pretty good goal. And the big reason for this is, as with technical problems, as with coding problems, a lot of times these are going to have follow-up questions. And so we don't want to spend, 5 minutes sort of rambling an answer and then not be able to get into, that part 2, part 3, get the naive solution out of the way and then improve. It's the same thing here. So yeah, I would shoot for 60 to 90 seconds as your initial response if you can. Remember, it's totally fine to take a second to think and construct your answer before you respond. So don't feel like, oh, they're done talking, I need to start talking now. Say, okay, let me think for a second and then give your response. 60 to 90 seconds for your first response is great. And then based on their reactions, they may have follow-up questions, or they may ask to dig in to some of the things that you said. So very common there.